Link comes area class.
Sir Rahul.
Okay, ji, sorry for the interruption. Problem is with the internet. Anyway, we were discussing the RE model, and in the आवाज आ रही है जी?
जी sir.
Okay, so in this, which you can see is the transistor with the base emitter junction. In between the base emitter junction, we have basically the property of the diode. So what we do with this characteristic curve, we are able to see that it is behaving as a diode. So therefore, what we do that we, in between the base emitter junction, we replace the transistor with a diode over here. And when we replace this with a diode, so we also know this thing that the other end of the diode is being connected to the base as well as to the connector. So therefore we are saying that the the total current which is flowing into the diode should be equal to the current which is flowing in the base as well as the current which is flowing in the collector, and which is basically from our previous knowledge that IE is actually equal to IC plus IB, and therefore we have actually made this circuit over here according to this equation, which is basically the emitter current is the sum of the collector current plus that of the base current, right? So therefore we are coming up with this kind of an arrangement with the common emitter configuration circuit, right? Are you with me till this point?
Yes sir.
Yes, sir.
Right, so if we see over here that this is still basically equal to VBE, right? ठीक है जी?
Yes, sir.
And if we take a look further on with the circuit for the output side, so the output side, if you see, it is basically the circuit which is having the output current which is equal to IC, and the voltage is basically VCE, right? So from the characteristic curve for the common emitter configuration circuit, we had seen previously that the characteristic curve is between VCE and that of IC, right? And the curves are according to the base currents, which we normally say it is IB1, IB2, IB3.
इसका थोड़ा सा कंक्लूजन रहने दे, फिर और टॉपिक फिर पढ़ लेंगे। इसका कंक्लूजन रहता है।
Okay, Ji. So again, can you see it and listen it? आवाज आ रही है जी?
यस यस दिख भी रही है।
Okay, Ji. So as you know, we have basically the curve for the output characteristic curve, which is in between IC and VCE. And for different value of IBs, we have different value of IC, which is flowing in the output circuit. That is according to basically beta values, right? Now, and we also know this thing that IC is actually equal to beta times IB, right? Are you with me?
Yes, sir.
We know this
Yes,
thing
sir.
from our previous knowledge that the collector current is actually equal to beta times IB. So if we take a look of the same circuit over here, and if we just replace IC with beta times IB, so the circuit will be looking as something with a modified version. The circuit will be looking something like this, that if we say this is the diode over here, the current flowing in the diode is IE, the current flowing in the base is IB, and the current which is flowing in the collector is beta times IB. Now
सर जी स्क्रीन हैंग है.
एक
स्क्रीन
मिनट
सर जी हैंग है.
आ जाएगी. Okay, so
आ गया सर जी.
the current which is flowing in the collector is basically beta times IB, right? Now, if you see this beta times IB can be represented as a current source which is being dependent upon some other current source, right? So it is basically beta times IB, which is basically the current which is equal to IC over here, right? So what we say from here, that this will be actually equal to our VCE, which is in between the collector and emitter junction, right? ठीक है जी. And this is basically VBE, which is our input side, right? So this is positive, this is negative. Similarly, this is positive, this is negative, right? Over here.
सर जी स्क्रीन ही गायब हो गया.
Okay जी, आवाज आ रही है जी? Okay, so if you see, we have the input side which is in between base and emitter junction. We have the output side which is in between the collector and emitter junction, right? So what we have basically, we have now a diode which is in between the base and emitter junction. We have a current controlled source which is in between the collector and the base, which is being represented by beta times IP. Are you with me?
Yes, sir.
Okay, ji. Now if you see, what we can say that there is an input impedance for the system, right? And the input impedance for the system is basically that is the input voltage to the input current. But before we go into that, and we say that the diode is having an resistance which is normally called as, the diode has a resistance which is normally called as RD, right? And if you just go back to chapter number 1, the RD is being represented with an equation which is RD is equal to 26 millivolts divided by the current which is flowing in the diode. Now this is the equation which is actually provided in the book. If you go to chapter number 1 of the book, and in, just let me show you where it is. This is the same book which I have shared with you people, right? Now if we go back in chapter number 1,